Welcome to today's lesson. Okay, so last time we looked at sets when we learned how to represent sets and how sets go on. Okay, so the first thing in this lesson we are going to look at subsets and power sets and Venn diagrams. Okay, so these all are part of sets. Okay, so make sure you remember what happens in these sets. Okay, so in this lesson we have our learning objective. So by the end of it, I'm going to make sure you're going to be able to use Venn diagram to represent the relationship between sets. Okay, so you're going to be able to draw a Venn diagram and be able to understand it what it represents. Then the other thing, you're going to use the basic set operations like union, intersection, and difference, then a complement. Okay, so these are the four operations we are going to use when we operate the sets. Okay, then the other thing is we are going to understand and write a power set. Okay, so we're going to understand what is a power set and be able to write it. Okay, then the other thing, we're going to identify subsets of a given set. Okay, so given a set, let's say A, we're going to understand how to write subsets and identify them using that. Okay, so this is our lesson today. So make sure you're subscribed so that when you go to the next lesson, we are going with all basic maths and we are going to be learning advanced maths very soon. Okay, so make sure you are subscribed so that you don't miss any topic of your choice because they're going to be there. First, let's understand what is a subset. Okay, so a set is a subset of, let's say we have a set A is a subset of set B if every element of A is also in B. Okay, so let me rephrase this. A set A is said to be a subset of B if every element in A is also in B. Okay, so let's say we have our set B here. Our set B has these numbers 1, 2, 3, 4, 5. Okay, so let's say this is our set B. Okay, so a set A is said to be a set of B. Let's say a set A has elements 1, 3, and 5. Okay, so this A is a subset of B. A is a subset of B if all these elements are in B. You can see that here 1 is there, 3 is there, and 5 is there. Okay, so we can see that all these elements are in B. Okay, so we can simply say that A is a subset of B. Okay, so this is what is the meaning of a subset. Okay, so we have a set, a bigger set. Let's say we have a set of alphabet letters. Okay, so we have alphabet letters, and we have a set A which contain of vowels. Okay, so in vowels, alphabet letters, they are also contain vowels. Okay, so this means that this this set A is a subset of this universal set. Okay, universal set is represented by this sign or this U. Okay, so we can simply say that this A is a subset of B. Okay, so that's the meaning of subset. Okay, so make sure you remember this because when we start to do this subsets and power sets, you have to make sure you know. Our next concept here is a power set. Okay, so a power set is said. Let's say the power set of A is the set. Okay, of all subsets of A. Okay, so let me repeat here. The power set of A is a set of is the set of all subsets of A. Okay, so let's say we have a set A here. It contains all these 1, 2, 3, 4, 5. Okay, so a set can contain any numbers, can contain anything. But let me say the power set of A is a set of all subsets of A. Okay, so we have to look at how many subsets we can make here. Okay, so I told you that if we have a set, let me represent with small letters. We have set A here, it only contain 1. Okay, so and we have another set B, it can only contain 2, and we have our set C, it can contain 1 and 2. Okay, so the number of sets we can make, okay, how many sets we can make, a set of all these. Okay, so this means that let's say a power set of A is the set of this A, B, C, and so on and so on. How many sets can we make from this? How many subsets can we make from this? Okay, so this is the meaning of power set. Okay, so a power set contains the set is a set of all subsets of A. Okay, so make sure that how many subsets. Okay, so to know how many sets we can make, just say that we have, let's say 1, 2, 3, 4, 5. Okay, so let's say we have 5. Okay, so to find the number of power of subsets A, we just have to make sure that we say 5 to the power, we say 2 to the power n. Okay, so our n in this case is 5. Okay, so this means that we are going to say 2 to the power 5. Okay, so this will give us number of sets where we can make of this. Okay, so this is as easy as that. If you want to know how many sets we can make from A, how many subsets we can make, you just have to say, count the number and say 2 to the power that number. So it becomes 2 to the power 5 in this case. Okay, so that's the meaning of power sub of power set. Okay, so make sure you're able to find the power set of any set. Okay, so that was that. Let's go to the next concept. Make sure you understood what is a power set. Okay, our next concept here is Venn diagrams. Okay, so Venn diagrams are visual tools. Okay, so these are diagrams. They are visual tools to represent sets and their relationships. Okay, so given many sets and a universal set, we are able to represent these using Venn diagrams. Okay, so let's say we have a set here. Let's say we have a set A which contains numbers less than 10. Okay, so let's say there are natural numbers. Okay, so let's say there are natural numbers less than 10. And we have a set B here. It represents even numbers less than 15. Okay, so here is what you have. Okay, so let's now talk about this set. Okay, so to represent this on Venn diagram, we just have to write a circle like this. Then we write another circle. Okay, so when you see that these can intersect, you just have to include a portion where they can intersect here. Okay, so let's fill the elements of the first thing is you write the elements here. Here we have the natural numbers. We start from 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so they are less than 10. Then here we have to see that if a number is less than 15. Okay, so here we start from 0, 2, 4, 6, 8, 10, 12, 14. Okay, so these are even numbers. Okay, so the first thing you just have to check which numbers are common in these two. Okay, which numbers are common in this. Okay, here we can see that 2 is common, so we write 2 here. Then we can see here 4 is common, so we write 4 here. Then we can see that here 6 is common, then we write 6 here. Then we write 8 is common here, and then you write 8 here. Okay, so these are the only ones which are common. They have this special place. Now, now we just have to write the remaining numbers of A. In this case, we're going to give 1, 2, 3. Okay, then we just have to write the elements of B, which are, okay, so that was that. We just have to complete, we have completed our Venn diagram. Okay, so if you can now say these are universal set, you can find a way to represent all these numbers. Okay, so you can represent in this rectangle, which means that a universal set. Okay, so that's the meaning of the Venn diagram. Okay, let's go to the next concept here. Let's take a look at the basic set operations. Okay, so these are the operations we do between sets. Okay, so let's say we have a set. I'm going to use this set to illustrate. Let's say we have set A. Set A contains numbers less than 10. Okay, natural numbers less than 10, which are 1, 2, 3, 4, 5, 6. Okay, so these are natural numbers less than 10. Okay, so now let's say set B contains numbers, even numbers less than 10. Okay, so here we have 0, 2. Okay, so these are the numbers we have. Okay, now let's say we have a our universal set. Our universal set contains whole numbers less than. Okay, so this is our universal set. Okay, so let's talk about basic operations. Okay, universal set, this means that all this set, they come out of this. Okay, so this is what we call a mother set. Okay, so a universal set here, we can call it a mother set. All this set, they come off of this universal set. Okay, so let's start learn by the first operation, which is called the union. Okay, so if you say A union B, okay, so this means that we are taking all elements of A and combining them with the elements of B. Okay, so this means that we just write all the elements. Here we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we can see that here we have written 2, it is in there, and here is there and there. Okay, so now we have all written all these sets. Okay, so we just have to cancel them out. Then we have 0. Okay, so now we just have to write 0. Okay, so these are the sets where we can go A union B. Or you combine A and B. You don't repeat the elements, just combine them. Okay. Then the other thing is A intersection B. Okay, so intersection means that they are in B and they are also in A. Okay, so they are in common. They are common in both ways. They are in A and they are also in B. Okay, so here you can see that in this case we have 2 and 4, 6 and 8. Okay, so these are common in all these things. Okay, then the other thing is A difference B. Okay, so it is the meaning by the a minus M here. Okay, so we can say that it's a minus in this. Okay, so it means that A difference B. Okay, so this means that we just have read everything that is in A that is not in B. Okay, in A, not in B. Okay, so we just have to write everything in A, not in B. Here you can see that 1 is not in B, and here 3 is not in B, 5 is not in B, 7 is not in B, 9 in B. Okay, so that is the meaning. Okay, then the other thing is, let's say A complement. Okay, so it is represented by this, or we can say A complement like this. Okay, this is the meaning of A complement. Okay, so this means that all the elements that are in universal set, they are in our universal set, but they are not in A. Okay, so this is the meaning A complement. Okay, they are in our universal set, but they are not in A. Okay, so in this case we only have one element like that. Here is 0. Okay, so 0 is in our universal set, but it is not in A. Okay, so this is easy way you to understand this. These are only our operation. We have union. We just have to combine. Okay, okay. Then you have intersection. Okay, intersection is common elements. Okay, these are common elements. Okay, so you know that the elements are in both, and we can write them. Okay, then here we have a difference. Okay, so the difference is the elements which are in A, not in B. Okay, so in one set, not in another. Okay, then here we have a complement that which are in universal set, universal, but not in that set. Okay, so this is the meaning of a complement. Okay, so that was that on our set operations and subsets, power sets. Okay, so that was that. Make sure you are subscribed so that the next time I'm going to be looking at this set, I'm going to take an exam question and show you how it is asked and solve different problems, solve different real life problems with it. Okay, so make sure you don't miss that video because you will have subscribed.